Simplifying Radicals, a guide for dummies by Ethan Wilden. LOL, what's a radical? Some of you may be asking what this strange term is. A radical isn't an extremist Mormon or a strange plant, maybe some planet far away. Alas, I have the definition for you to sate that unhealthy appetite of yours. A radical is an expression with a square, cube, cortex, so on and so forth root. Why do I want to simplify it? Well, duh, radicals are all over the place. What if you want to know how much that electricity bill is going to cost? Those equations have radicals in them. Gotta figure that out, bro. Electricity isn't cheap. So if you ever want to have any sort of job in physics, motion, engineering, electricity, teaching mathematics, computer science, and just about every other technological job in the whole flipping world, so simplifying is important. So, some terms. Index, the argument of the radical. If no index is shown, it is always 2. March Madness bets, things not to make with Josh Kirkwood. A loser, people who cannot simplify. A stud, oh, sorry, my bad. A student, me, Mrs. Sarami. Now, how to do so? So how does one simplify a radical? Great question, Lassie. My friend / pal Hal will gratefully describe it to you.
Welcome to Simplifying Radicals for Dummies by Ethan Wilden and his good pal Hal. Step 1. Find the prime factorization of the number. Divide by 2 until it is no longer divisible by such. Then attempt to divide by 3, 5, 7, 11, and so on and so forth until prime factorization is found. Step 1.5. Commit a silly March Madness bet against your arch nemesis, Hal, aka Mr. Kirkwood the Fraulein. Step 2. Determine the index of the radical. The index is your guide for how many of a kind of number you bring to the outside. Step 2.5. Wear a wig of shame and a humiliating t-shirt for losing your silly bet to Mr. Kirkwood, the Fraulein. Step 3. Move each group outside of the radical and multiply them together. Step 4. Simplify outside and inside by multiplying the numbers together. Step 5. Listen to the evil lisp laugh of shame for losing another bet to your arch nemesis.
So now that we're done, JK examples. I'm going to have you simplify root 252. First, you'd have to find the prime factorization. So it'd be 2 times 2 times 3 times 3 times 7. Now since the index is 2, you have to pull out groups of 2. You would have 2 times 3 root 7. To finish simplifying, we would multiply 2 by 3 to get 6 and end up with 6 root 7. Your ended product and simplified radical is 6 root 7. The end. Ha! Not more radicals. Since the index in this one is 3, it'd be called a cubed root. So we have cubed root 504 x to the 4th y cubed. First we would find the prime factorization. Okay? Got it? Good. It would be like maybe 2 times 2 times 2 times 3 times 3 times 7 times x times x times x times x times y times y times y. It's a really big number. So we're just going to simplify it to 2xy cubed root 3 times 7 times x. After simplifying, we have this awesome number. 2xy cubed cube root 21x. It's so simple. Another number. This time we have an index of 2, so we would just call it root 3666 x to the power of 12 y to the power of 27. Alright, let's just cut to the chase here. First we would find the prime factorization. 3666 divided by 3 would be 1222, divided by 2 would be 611, divided by 13 would be 47. The x and y's are just going to be end up as 6 x's on the outside and 13 y's on the outside. So we get this number. 3x to the 6th, y to the 13th, root 2 times 47. Or 3x to the 6th, y to the 13th, root 94y. So, yeah. This is the real end, bro. Sorry, I know it's kind of hard to take in, but it's over.